It's a tool of engagement. It's because it's virtual, it's meeting students exactly where they are. It's giving them the opportunity to experience those things that students desire.
I have this big need to create, getting to know how stuff in the real world works, learning the information behind all that, and being able to learn that myself and teach others. That'd probably be the best part of VR development for me.
I think that this is a great tool for teachers to teach physics and for students to learn it and then be able to see it being applied in the real world. It gives an opportunity for a teacher to have the message from the textbooks experienced by the student.
It's fun getting to take knowledge from my old job, bring it over to this, make it apply with science, friction, all that.
You imagine a shuffleboard table. You're normally sprinkling this powder onto the table, but we decided let's just make there be buttons where you can adjust the friction of any part of the table that you want.
I don't even play shuffleboard, but I was so impressed. And it seems like it's just a game, but you're learning.
And how can I conceptualize the difference between static friction versus sliding friction through gamified activities like shuffleboard?
If there would be one element of the physics application, it would have to be learning Newton's law by skydiving. For me, that was so exciting. As a paratrooper who's jumped out of an airplane, and to see the science of what is taking place of an experience that happened to me over 30 years ago is probably the most amazing component to it for me. It's things that you would never imagine unless you did it. Well, I can't front, the hot air balloon is incredible as well.
One of the things that I hear all the time is that students have a hard time thinking about the concept of a free body diagram. And so we show you, as you are rising up into the atmosphere on this balloon, we actually show you the force of your buoyancy in that balloon increasing over time relative to your gravity. And so you're actually understanding these forces that are acting on you and the balloon as you rise up 100 meters into the air. Hope you're not afraid of heights.
The best part would probably be getting to 3D model an entire bowling lane to scale.
Oh, the bowling alley, the bowling bridge, as I like to call it, actually. So Jeremy, he's a bowler. He absolutely loves it, and I told him that I wanted to have a bowling alley in the physics lab to teach about Newton's laws of motion and rolling friction, and he says, can I build it to scale? I say, okay, sure, fine.
Didn't have a good concept of their actual scale, so he had to remake almost all of his building just because I kept complaining that I was not going to let him shrink the bowling lane.
I've already designed the building for the physics lab at this point, and I bring in his model, and I think there's no way I can get this to fit. Completely adding on a whole other section. You gotta go upstairs and go to this platform, and it extends out over the road, and now we have the bowling bridge with a full-scale bowling alley.
So I'd say probably getting to see his reaction
At Jeremy's request.
Demands and getting the bowling lane in there would probably be the best part about the physics lab.
Yeah, any building that you think should have a bowling alley, come to me, we'll talk. I'll help you figure out where it can go.
When I tell you that this is an incredible learning tool, it's making me feel like I could really enjoy science.